Greetings, everyone. This is for the true and false of the Chapter 15 practice test. So you're answering these as they come up. Cavalieri's principle is a way to prove that two solids have the same surface area. What do you think? Volume would make it true, not surface area. The lateral faces of every prism are rectangles. Parallelograms. It says right in the book, in 15-3, if you want to see that reference, page 635. Parallelograms. In a right cone, the cross sections that are parallel to the base are circles. True. If they're parallel to the base. If we're not parallel to the base, they become more like ovals. D, all rectangular prisms boxes are similar. We might be tempted to say yes to this. Certainly true of cubes. But it is possible for rectangular prisms. Remember, the corresponding side lengths have to have the same ratio. And it's possible that the length might have one ratio and the width might have a different ratio. And the height still another one. So all three of them would have to be the same. So this question is false. If two planes are perpendicular to a third plane, the planes are parallel to each other. We might be tempted to answer true to that. But you have to picture, remember we talked about the back corner of the room. And it's hard to reproduce that. But if this is where the two walls intersect in the back corner of the room, okay, and this is the floor here. Now both of those walls that intersect in the back of the room there are perpendicular to each other, but they're also perpendicular to the floor, right? So if two planes are perpendicular to a third plane, the planes are parallel to each other. Well, we can see that that is not always the case. That if we look in the back corner of the room, we see where the two walls meet. If that was the case, then the two walls that meet in the back corner of the room would have to be parallel to each other because they're both perpendicular to the floor, also both perpendicular to the ceiling. So we found a counterexample. Just because they're perpendicular to the same third plane doesn't mean that they're parallel to each other. They can be, but all we need is one counterexample to make it false, and we've got ours. The two walls are perpendicular to each other where they meet. They're also perpendicular to the floor. But since they're both perpendicular to the floor, according to this, then they should be parallel to each other, which they obviously are not. So it's false. A lot of falsehood running rampant here in these questions. So make sure that you absorb all that information so you've got it. See you on the next one.